Alright, so circles and lines sometimes intersect on the graph. We've already talked about graphing circles. Sometimes you've got these intersection points between a line and a circle. There's three options. Either the line's not going to come anywhere near the circle, I mean obviously it's near the circle, but it's not going to cross into the circle in any way, shape, or form, and that means there's no points of intersection. Then you've got the option where the line touches in exactly one place out on the edge of the circle. This is actually called a tangent line. It creates one point of intersection. And if the line goes through the circle, it touches in two places. There's no other options. It's either 0, 1, or 2. So what I've done is you've got two options. You've got graphing, and I've gone ahead and graphed the circle part of it. But you can solve by graphing them out and taking a look and seeing, is it nothing, is it one place, is it two, or you can solve it algebraically. So to start by graphing, the first thing you do is you graph your circle. And then the next thing you do is you get the y by itself so that you can graph the line. I need it in y equals mx plus b form. So I subtracted the 2x, and then I divided by negative, and I got 2x minus 5. So when you go to graph the line, you start at negative 5, and I go up 2 and over 1, up 2 and over 1. So it looks like it gets really close, up 2 and over 1. But in fact, it doesn't actually touch the circle at all. So this is no points of intersection, or none. Okay, so the next circle I've already graphed for you. This is y equals negative 5. What that means is I go down here to negative 5. Let me pick a different color. I go down here to negative 5, and if y equals negative 5 and it only equals negative 5, that means it always equals negative 5. That means it touches in exactly one point, and it crosses right here. So the point of intersection is at the point 3, negative 5. So there's one point of intersection and it's right there. Next we have got a circle already graphed, and then I've got x plus y equals 3. So I'm going to get y by itself by subtracting x from both sides. So I get y equals negative x plus 3. This means I start at 3, and I go down 1 and over 1, down 1 and over 1, down 1 and over 1. Alright, because it's a negative slope. So this particular graph has 2 points of intersection. It crosses right here at the point 0, 3. Show you where I did that. I'm sorry. I graphed here. I started at positive 3 and went down 1 over 1. Drew the line. So it crosses here at the point 0, 3, and it crosses here at the point 3, 0. It's not necessary for you to circle them. I'm doing that for the point of notes. Let's see if I can do this one where you can actually see it. Alright, so this one, I have got to get the y by itself. The only thing left to do to get that y by itself is divide by 2. So I'm going to divide everything by 2. So this is y equals, and this is the same thing as 1/2 x plus 8. Excuse me, 4. 8 divided by 2 is 4. So I'm going to start up here at positive 4. I'm going to go up 1 and over 2. I'm going to go down 1 and over 2. Down 1 and over 2. So on and so forth. This is another situation where there are no points of intersection. Okay, so there's my graph, graphing to find the points of intersection. Then you've got algebraic. Alright, so this way, first you need to solve the linear for one variable. It doesn't matter which one, you can pick either way. Then you need to substitute that variable in. So let's just do one step at a time. Step 1, solve the linear equation for a variable. I'm going to get x by itself. So x equals, I'm going to add y to both sides to do it, y plus 2. Okay, x equals y plus 2. If x is y plus 2, I then substitute it in to my equation. So I'm going to say y plus 2 squared plus y squared equals 34. Alright, I square this by doing y plus 2 times y plus 2. So this is y times y is y squared, y times 2 is plus 2y, plus 2y, plus 4. So that is the same thing as y squared plus 4y plus 4 plus y squared equals 34. Now I'm going to combine my like terms, and I want to set this up. I see some squareds, I see a linear term, I see numbers. If I can get everything over to one side, I can probably solve it just by solving a quadratic. So this is going to be 2y squared plus 4y. I'm going to subtract 34 from both sides. So this is going to be minus 30 equals 0. At this point, I'm going to try to factor by borrowing. Y squared plus 4y minus 60 equals 0. And what are some options for 60 that would give me, multiply to give me 60 and add up to give me 4? Well, 10 and 4 would work. So I'm going to make that y plus 10, y minus 4, 6. I don't know where I got 4 from, I'm so sorry. 6, because they add up to give me 4. Then I've got to pay back the 2. So I get y plus 5 and y minus 3 equals 0. So my options are either y equals negative 5 or positive 3. Well, I take both of these and I plug them back into my original linear equation. Or I can plug them in right here actually. So x equals negative 5 plus 2 or x equals 3 plus 2. So when y equals negative 5, the x value is negative 3. When y equals 3, the x value is 5. Those are my two solutions. Let me demonstrate another one for you. Again here, I'm going to get x by itself, so I'm going to subtract 3y to both sides. So I get x equals negative 3y plus 10. So I'm going to substitute this in for my x. Negative 3y plus 10 squared, I'm just going to write it as negative 3y plus 10 plus y squared equals 10. I'm going to square this by multiplication. So I get 9y squared. This is going to be minus 30, so minus 60y plus 100 plus y squared equals 10. Combine my like terms and bring over the 10. Okay, solve it by any method for solving a quadratic equation. So this is going to be adding these. It's going to be 10y squared minus 60y, and then I'm going to subtract this over, so plus 90 equals 0. Well, I can factor out a 10, so I'm going to do that. So 10 times y squared minus 6y plus 9 equals 0. Well, the 10 just goes away. This simplifies, factors out, into, see the two numbers that are multiplied to give me plus 9 but add up to give me negative 6. Well, that is just minus 3 in both cases. So that means that y equals 3, and it only equals positive 3 because it's repeated. So now all I have to do is plug a 3 back into my linear equation. So x equals negative 3 times 3 plus 10. So x equals negative 9 plus 10, which is just 1. So x equals 1, y equals 3. The point is 1, 3. So I'll let you guys try the last two, and we'll discuss it in class.